atoms, they're composed of these things called subatomic particles. So we have an atom, and let's just do carbon for now. So we'll have 1, 2, 3, 4, 5, 6. And those are my protons, and then I have neutrons. 1, 2, 3, 4, 5, 6. And then I have an electron cloud around this. 1, 2, 3, 4, 5, 6. Okay. This is an atom. This is a carbon atom. Okay. This is a carbon atom. And a carbon atom is going to have 6 protons. It's going to have 6 neutrons. And it'll have 6 electrons. And these 3 things are called subatomic particles. And sub means underneath. So in terms of structural organization, this is the level underneath an atom. These are subatomic particles. If we talk about where we find these, we find the protons and the neutrons in the nucleus, and the electrons float around. If you have to ask yourself, okay, I have an element. Let's just go with. Let's go with hydrogen. That's number 1. So if I have a hydrogen atom, I have 1 proton. How many electrons do I have? 1. Right. So the idea is that however many protons you have the same number of electrons. You identify elements based on the number of protons that they have, not the number of neutrons or electrons. When you change the number of electrons, you're going to influence the charge. When you change the number of neutrons, you're going to create isotopes, which we talked about whenever we talked about that imaging technique earlier. Okay, subatomic particles. So that isotope, an atom with the same number of protons, because if it's going to be a carbon atom, it has to have 6 protons. And it normally has 6 neutrons, but let's say I add 1 more, so I have 7 neutrons. So instead of being C12, this is C13, and this number comes from the 6 protons plus 7 neutrons. And this is for carbon 13. All right. Proton. It's positively charged. Neutron. Whoops. Neutron. This has no charge. Electron. Negatively charged. So once these things once anything, atoms gain or lose electrons, that's going to influence charge. And once you influence charge, then you can influence things like electrical energy. So we're starting to make connections between these concepts. Protons and neutrons, the mass of them are approximately equal, and they both have more mass than an electron. Electrons are way smaller, less mass. And they float in that electron cloud that orbits the nucleus. So back here, we had this. This was the electron cloud orbiting our nucleus. Okay. So, question. Where is majority of the mass located? And why? Good question to ask yourself whenever you're testing yourself is, and why? So most of the mass is in that nucleus. And why? Because protons and neutrons have more mass than electrons do. And even if they're the same number, like 6, 6, 6, and 6 with carbon, those protons and neutrons have way more mass. So most of the mass is in the nucleus of an atom. Okay, electron, energy levels, orbitals. If this is my atom, sorry, that's my nucleus. This is the boundary of my atom. Well, we don't know exactly where electrons are, but we have an idea. We have an idea of distances, and these are called energy levels or orbitals. So maybe you have an electron here, or you have one here. We don't quite know. You can't measure where something is and how it's moving at the same time. The most outer shell, so this one out here, this is called the valence shell. The valence shell of electrons is important because these are involved in chemical reactions. You want this outer shell to be full. When it's full, it reaches, when it has a full energy level, then it's in what we call noble gas configuration, and it won't react. Things want to be as as stable as possible, as chill as possible. They don't want to react, so they'll react to become stable. And one way to do this is to fill up this outer valence shell and get noble gas configuration. So let's talk about the difference between an element, a molecule, and a compound. So an element is any substance that can't be decomposed into smaller substances by ordinary chemical reactions. They're made up of atoms, which are protons, neutrons, and electrons. So the human body has 24 elements: oxygen, nitrogen, carbon, hydrogen. Those make up 96% of the human body. We also have calcium and phosphorus, and the other 18 elements are called trace elements. We need them to survive. They play a bunch of different roles in our body, but just not the majority compared to these other elements. Okay, the big one that confuses people is, what's the difference between a molecule and a compound? So I do compound first, and then molecule over here. And the way I do this is, what's the letter that comes after C? D. So when I see compound, I write a D up here. And for D, I put different. For molecule, I put the word many. The other word you can use up here for molecule is multiple. So this is, the idea behind this is, you need to ask yourself, what is my, whatever I'm looking at, what's it composed of? So let me just write some examples. We'll write NaCl, we'll look at H2O, we'll look at H2CO3, you don't have to know what any of these are, it doesn't matter. H3PO4, and we'll do O2. So the question I want to ask myself the two questions I want to ask myself: do I have the same, I guess it's one question, do I have the same or different elements in whatever I'm looking at? Okay? O2. That's the same, right? So this is a molecule. Na, and then I have Cl. So these are different. So NaCl is a compound. H2O. H2O, you have an H, you have an O, so this is a compound. But this is where it gets tricky, because this is now where you have the word many. So O2 was multiple. You have multiple of the same thing. I have multiple O2s. That's what defined this as a molecule. This time you have many, so more than one atom. Anything that's more than one atom is a molecule. Stay with me on this one. Let's keep going. H, C, and O. So I have different elements. So I know this is a compound. But then I look over here and I say, well, do I have many atoms? I do have many atoms because I have 2 hydrogens, I have a carbon, and I have 3 oxygens. So this is also a molecule. Let's do it one more time. H, P and O. I have different elements. Since I have different elements, that means this is a compound. But then I look over here. Do I have many molecules? Yes. Sorry. Do I have many atoms? Yes. So this is a molecule too. So the whole point, if you have to ask yourself, all compounds are molecules, but not all molecules are compounds. Where do you see that? This is a molecule that is not a compound. I have multiple oxygen multiple oxygen atoms, but they're not different elements here. All these other ones, NaCl, Na and Cl, those are two different elements, so that makes it a compound. But it's also more than one atom, so it also makes it a molecule. Okay, so if these are all confusing, let's just do one just to clear the air. And we're just going to say CO2. The question I asked myself, different, many, multiple. CO. Are those two different elements? Yes, that means CO2 is a compound. Now for the criteria of a molecule. Are there many atoms or are there multiple atoms? And multiple, this doesn't mean O2 here, that doesn't mean multiple. Multiple means it's like singularly by itself. Okay, so this means that CO2 is a molecule and a compound. If I went with O2 just for practice again, first question I asked, do I have different elements here? No, I do not. So I cannot say that it's a compound. But then I say, do I have more than one atom? Do I have many atoms? Do I have multiple of the same atom? Yes, so I can say this is a molecule. So that's what I'd ask myself. All compounds are molecules, not all molecules are compounds. Re-listen to that if it's still confusing you a little bit.